a fully reprogrammable quantum computer has been built and tested for the first time. The test marks a milestone in the development of powerful problem-solving machines that harness the strange properties of subatomic particles. At the heart of the device are just 5 ions, electrically charged atoms, trapped in a magnetic field, which are vibrated by precisely targeted laser beams. By manipulating the ions in ways that exploit their ability to be in more than one state at the same time, the essence of quantum computing, scientists were able to run programs that would be difficult or impossible for a conventional computer. One involved performing a calculation in a single step that would normally require several stages. Another demonstrated a quantum Fourier transform, a mathematical operation that could be used to break highly secure encryption codes. Despite consisting of only 5 qubits, the quantum computing equivalent of bits of information, researchers from the University of Maryland say their quantum computer module is highly flexible and could be scaled up. Quantum physicist Professor Christopher Monroe said, "Our experiment brings high-quality quantum bits up to a higher level of functionality by allowing them to be programmed and reconfigured in software." Conventional computers use long strings of ones and zeros representing on or off states to store numbers, letters and symbols and perform calculations. These are the bits. For instance, in computer language an uppercase A is 1,000,001. However, a quantum computer qubit can be a 0 or a 1, or in fact any combination of the two simultaneously. This is due to the strange laws of quantum mechanics, through which subatomic particles live in a ghostly world where there is no hard and fast reality, only a myriad possibilities. They remain in a multiplicity of simultaneous states, known as superpositions, until they are observed or disturbed. Only then do they collapse down into one state or another, just as a spinning coin turns up heads or tails when caught. By using qubits, quantum computers could theoretically solve complex problems that would defeat the most powerful classical computers. However, making quantum computers a practical reality is a huge challenge. A number of devices have been built that perform just one function and cannot be programmed to run traditional software. However, the new computer from the University of Maryland has taken quantum computing to a new level by being programmable. The machine uses its laser-manipulated ions to drive quantum logic gates, the equivalent of the switches and transistors that power ordinary computers. It also exploits a strange quantum phenomenon called entanglement, allowing individual ions to lose their independence and behave as if they are part of a single system. 3 algorithms, sets of rules used to run a computer program, were tested on the device. 2 ran successfully more than 90% of the time while the QFT had a 70% success rate, according to the paper, published in the journal Nature. None of the errors involved were fundamentally insurmountable, said the researchers.